Hey everyone, in this video I'm going to be talking about section 9.1 in the Envision book, Conic Sections, where we will be focusing on parabolas. Alright, so conic sections are probably new. So let's talk about what a conic section is real quick. So a conic section is the intersection of a plane and a cone. There are a few different types of conic sections. The first one is parabolas. And that's going to be our main focus. There are also circles. I'm pretty sure you learned in geometry, ellipses, and hyperbolas. But again, our main focus is going to be parabolas. So let's talk about a parabola. So this is going to be a little bit different. So the definition of a parabola for a conic section. A parabola is the locus of points in a plane that are equidistant to a fixed point which we call the focus. And a line which we call the directrix. Okay, so let's do a visual. And I'm just going to sketch this, so it doesn't need to be totally accurate. Okay, so the directrix is a line for this visual. I'm going to do a horizontal line here. Okay, so the directrix is going to be a line, in this case horizontal. It's not always horizontal. And then we have a fixed point, the focus. So I'm going to go up here and put an F for my focus. And the parabola is the locus of points in a plane that are equidistant. So equidistant between the focus and the directrix is right here. And that's going to be the vertex. And then every point in our parabola, and this will be a little challenging. Just do it like this. Not the best visual. We're doing what we can. We're not being a computer. Okay, so the distance between all of these points, right, here and here, is equidistant. If we went further, it would be equidistant. And then right here, this one's important, the first one. So the distance between the vertex and the focus and the vertex and the directrix is going to be what is called our p-value. Okay, so the distance, and this is what I did in green, the distance between the focus to the parabola is the same as the directrix to the parabola. So you could almost think of it as like this has like a little pulley, I guess. It's moving to the left and to the right. This is fixed and they're equidistant, and we have like a pen or a pencil. So as a string is attached to both of these, as we move to the right, as we move to the left, it's going to create a parabola. Okay, the p-value, which I mentioned, so the p-value is very important. The distance from the vertex to the focus and directrix is the p-value. So focus to vertex, that is a distance of p, and vertex to directrix are the distance of p. The three most important parts are four, I guess. So the focus is going to be very important, the p-value, the vertex, and the directrix. You need to have each of these three things. I mean four. 1, 2, 3, 4. 4 things, sorry. So let's introduce standard form of the equation. So standard form for the equation of a parabola, there are two because parabolas can face two different ways. There's y minus k squared equals 4 times the p-value, in parentheses, times x minus h. Or, incredibly similar, the only difference is instead of y minus k being squared, we could have x minus h being squared. We still have the 4 times p, and then this is going to be y minus k. So the only difference is what is being squared. Is it the y minus k or is it the x minus h? And h comma k is the vertex. And that's very similar to how you've learned about parabolas in the quadratic sense. Okay, so there's 4 types of graphs, and this will be the last thing for this video. The 4 types of graphs depend on if it's x squared or y squared. So let's say it's x squared. And then the thing that also depends is 4 times p, is this positive or negative? So if it's x squared and p is positive, we will be opening upwards. If it's x squared and our 4p is negative, we will be opening downwards towards negative values. If it's y squared and p is positive, we will be opening up to the right. And if it's y squared and p is negative, we will be opening up to the left. So that is the introduction to parabolas for conic sections. We will be focusing on graphing next. So make sure that you have these notes copied down so that we can build upon it and talk about graphing parabolas.